Everyone, welcome back to the channel. I hope you are doing extremely well. Let's start with today's LeetCode DCC question. Product of array except self. This question has been asked in previous interviews of Amazon, Facebook, Microsoft, Asana, Apple, Uber, Adobe, Bloomberg, Oracle. Let's look at the problem statement. Question says, given an integer array nums, return an array answer such that answer I is equal to the product of elements of nums except nums of I. The product of any prefix or suffix of nums is guaranteed to be fit in 32-bit integer. You must write an algorithm that runs in O(n) time without using the division operation. So what question is saying, suppose we are given an array and it contains numbers like 4, 3, 2, 1. So what we have to do, we have to find the product of the array except that number itself. For example, if we want to find the value at this position, except this value, we need to find the product of the remaining elements. That is 3 into 2 into 1, that is 6. For this position, if we want to find the value, except this value, we want to find the product. That is 4 into 2 into 1, that is 8. Similarly, for the remaining two. For this position, we have to skip 2 and we need to find the product of 4 into 3 into 1, that is 12. And similarly for this, except 1, we have to find the product 4 into 3 into 2, that is 24. So we have to return this array. And also they have mentioned if we multiply all the numbers in the given array, it will be easily be fitted in the integer variable. It will not exceed that. So we don't need to worry about the data type we need to store these values. So it can be easily be fitted in the integer data type as mentioned in the question. Now let's see how we can solve this question. Taking similar example, 4, 3, 2 and 1. Suppose if we want to find the product or the value at this position in the answer array. So for that, can we say we need to know the product of all the elements in the left side of this number and product of all the elements in the right side of this number? If we know these two values, we can easily multiply this and this to get the value at this index. For example, the product of all the elements in the left side will be 4 and product of all the elements in the right hand side will be 2 into 1, that is 2. And if we multiply this 2, it will give us 8. So we can put 8 here and we can see except this number, the product will be 4 into 2, 8. So how we can solve this? Do we need to traverse the left side of this number and calculate the left side of the product and traverse the right side of this number and calculate the right side of the product? For that, if we do so, the time complexity will give, that means for each number we are traversing the whole array and there are n indexes. So in that case, the time complexity will go from big of n square. But they have mentioned that we have to solve this in big O of n. So how we can optimize it? Suppose before finding this value, if we pre-calculate the product of all the elements in the left hand side and product of all the elements in the right hand side, can we do so? Now suppose taking similar example 4, 3, 2, 1. Now suppose we want to find the product of all the elements in the left side of the number. Now suppose on the left side of this number, what is the product? Initially there is nothing, so we can write 1. Now for the left side of the product of this number will be 4. So we can simply write 1 into 4, 4. The product of the numbers on the left hand side of this number is 4 into 3, 12. Similarly, for this number will be 12 into 2, 24. So in this way, we can find the product of all the elements in the left side of the number. Now, if we ask what is the product of the left hand side of 2, we can easily go to this index and say it is 12. We can say it is 12. Similarly, we can do the same thing for the right hand side. If we do so, we have to start from right hand side. So for this number, there is no number in the right hand side. So we will keep 1. For this number, there is only one number, that is 1 into 1. We will write 1. For this number, 1 into 2, 2. For this number, it will be 2 into 3, 6. Now, we can easily say, suppose for this number, what is the product of the numbers in the right hand side? We can easily go to this index and say it is 6. Now, if we want to get the final answer, what we can do? We can iterate the numbers from 0 to n minus 1, and we can simply multiply for each index the left hand side and the right hand side values. If we multiply 1 and 6, it will give us 6. 4 into 2, it will give us 8. 12 into 1, it will give us 12. 24 into 1, it will give us 24. So we can see the answer is matching. So 6, 8, 12, 24, 6, 8, 12, 24. But in this case, what we have done? Have we followed this instruction? Yes, we are calculating the result in big O of n time. So for to calculate the left hand side of the product of each number, we need to traverse the array once, that is big O of n. Similarly, to find the product of right hand side, again we have to traverse the array one time. And to get the final answer, again we have to traverse the array one time. That means in total big O of n plus n plus n, which is equal to big O of n. And also they have mentioned without using the division operations. So we are not using anywhere the division operation. We are using the multiplication operation. So this condition is also satisfied. So this is the accepted solution. But in this, if you see, we are taking an extra space to store the left hand side of the value and to store the right hand side of the value. So can we reduce this space complexity? Now, optimizing space complexity. Anyway, the question demands that we need to return an array, right? That means anyway, we need this space to return the answer. So we will not consider this space as a part of space complexity. So if we don't consider that as a part of space complexity, so can we use this space as a temporary state? Now suppose given a number 4, 3, 2, 1. Now can, if we store any of this right product of the numbers, right side of the product of the number or left side of the product of number. Let's suppose we store the right side of the product of this number in the answer array itself. So our value will be 6, 2, 1, 1. From this, we can see. Can we modify this array to store the final result in this only? Store the final result in the same array itself. If we can do so, can we say our space complexity will be big O of 1? Because we are not taking any extra space. Extra space will is not required, right? If we are able to do so, because anyway this final answer we need, because the question itself demands that we have to return an array. So we anyway this will not be included in the space complexity. Now suppose after calculating the right hand side product, we have the values 6211. Can we, how we can modify? Let's see. Now suppose we have 6211 and the original value was 4321, right? Now, can we take a variable, since they have already mentioned, if we multiply all the numbers, we can easily store it in the integer variable. Now let's take a variable which is stored the left side of the product. Now initially, let's suppose the value is 1. For this index, can we say the left side of the product is 6? If the left side of the product is 6 and sorry, the right side of the product is 6 and the left side of the product is 1, so can we say the final answer at this position will be 6 into 1, that is 6. Now we are moving forward. That means for this number, the left hand side product will be different. That is previous value into 4. Now we will update the left hand side of the product with 4 into 1, that is 4. Now, if we want to know the answer at this position, what we can do? We know the right hand side of the product is 2 and the left hand side of the product is given 4. That means we can easily multiply 4 into 2, 8. Now for this, again, we have to update the LSP because now 3 is also present in the left hand side of this 2. So we will multiply 4 into 3. So it will become 12. For this position, the right hand side product is 1 and left hand side will be 12. 12 into 1, 12. Again, we will update this left hand side product with 12 into 2, that is 24. And we can find the value here is like right hand side of the product, that is 1 into 24, that is 24. So in this way, we can see we have used the final array which we are going to return as the intermediate steps also. In this only we have stored the right side of the product, and in extra we have used one variable which we can say it's constant space. And if we see the time complexity, we are iterating the array only 2 times. So we have reduced the space as well as time complexity. So if we talk about time complexity, big O of n time we are taking to calculate the right side of the product, and big O of n we are iterating to calculate the final answer. So in total, we are taking big O of n plus n, that is big O of n time complexity. And if we talk about space complexity, we are not taking any excess, we are taking only constant space to calculate this LSP, right? So we can say space complexity big O of 1. So this is the most optimized answer, satisfying all the condition given in the question. Now let's look at the code. First, we will find the size of the array, that is nums of size. And after that, we will create an answer vector in which we will store the answer. Let's suppose the name of the vector is answer. Now we will calculate the product of elements in the right hand side. For that, we will keep a variable right product side or right hand side product, initializing with 1. Now, starting from n minus 1, I greater than equal to 0, I minus minus. So for every index, we will store the product at the product of all the elements present in the right hand side. So for the last element, there is no elements present in the right hand side. So for that, we will store answer of I equal to 1, that is RSP. Now we will update the product RSP into nums of I. So in this way, we will calculate the product of all the elements present in the right hand side for every index. Now, again, now suppose we will calculate the product at left side, which is 1. Now we will update the answer vector with the product of, so for every index we have the product at the right hand side. Now we will update with the right hand side product into left hand side product. For that we will straight iterate the array from the beginning, and for every index, that is nums of I, sorry, answer of I will be left hand side product into what is present in the answer of I itself. So earlier for answer of I, it will give us the product at the right hand side, and LSP will give us the product at the left hand side. And after every iteration, we will update the left hand side product with the LSP into nums of I. So for the next number, this will be our the left hand side product. So in this way, we will calculate for all the indexes, and after that, we can return the final answer. Now let's try to run the test cases. We can see test cases has been accepted. Now let's try to submit the solution. So our solution is accepted. I hope the problem statement and the solution is clear. See, if you have any questions or doubts, mention in the comments below. See you in the next video. Thank you.